Welcome back to C++ discussions. Today we are starting our discussion with a famous quote. The quote is, we all are made of carbon, but it's our choice to be diamond or coal. Now we can discuss more about this quote. You can see something like a carbon which is existing different forms. A carbon which is existing as diamond as well as coal. This process is known as polymorphism. Poly means many, morph means forms. Polymorphism means many forms. A single entity which is existing in different forms. You can see a single entity carbon which is existing as a diamond as well as coal. Now we can think about our program. In program also, the polymorphism is something like a single function have multiple function definitions. Now depend on the time in which this polymorphism is taking place, polymorphism is broadly divided into two types. One is the polymorphism which is taking place at compilation time. Other one is the polymorphism which is taking place at runtime. Today we are going to discuss about compilation time polymorphism. Polymorphism is nothing but a single function name which have multiple function definition. The same way, what is a polymorphism in the real world? It is like a single carbon which is existing as a diamond as well as coal. Now we can write a small program and we can discuss how this polymorphism is working and what are the internals of this polymorphism. I would like to calculate the area of a rectangle as well as area of a square. I wanted to calculate the area of a rectangle as well as I would like to calculate the area of a square. This rectangle have a length as well as breadth, and this all the sides are equal. I am calling it as L. Now I am writing a program for calculating the area of the rectangle as well as I am writing a program for calculating the area of this square. Assume I am putting some function name as int area of rectangle. This function will take two arguments, the length as well as breadth. Here I am putting int length, another one is int breadth. This is one function. The implementation will be return length into breadth. This is the implementation. Now I am writing a function for calculating the area of this square. Here I am writing int area of square. Here I am taking only one argument, that is length. Length is same across all the sides. Here I am writing int length. Here inside this function I am writing return L into L. This is the function. Now in a program it will be like it is so difficult to recollect all the names. Now I am thinking such a way that instead of these different names, why can't I use a single name for calculating the area of this rectangle as well as area of this square? This concept is known as polymorphism. So now I am going to write a single function name and function definition will be entirely different. Now instead of these two different function name, I am going to write a single function name, that's area. But the implementation of this function should be entirely different. Now here I am changing the function name as area. This function name also I am changing as area. Now I have two functions. The name of one function is area, which is taking two arguments. I have one more function. The name of this function is also area, but this is taking only one argument. Now you can see the function definition is different, but the function name is same. This is known as polymorphism. Now you can see a single function name which is going to do multiple jobs. This function name or this function is going to calculate the area of rectangle as well as area of the square. That is why you can see, assume someone is telling like you do this operation, you do this, you go to there for purchasing something. We are keep on telling something to some fellow, finally he will tell boss I am getting overloaded. The same way you can tell this function name is going to do multiple things. He is going to calculate the area of the rectangle as well as he is going to calculate the area of the circle, not circle, area of the square. So this function is telling like boss I am getting overloaded. So you can tell this is an example for function overloading. Function overloading is nothing but a single function name, and these functions are differ by either number of argument or type of arguments or order of argument, or in other way this is a kind of polymorphism that is known as function overloading. A single function name have different function definitions. Now we can analyze a bit more and we can see how this is internally working, or how compiler is capable to identify this name without any ambiguities. We can study a bit more deeply about function overloading. Now I am writing the same function and we can see how this function overloading which is internally working. Function overloading is nothing but a single function name, but the functions are, implementations are entirely different. Now we can see I have one function int area. First time I am going to calculate the area of a rectangle, so I am using two arguments for this function. First argument is int length, second argument is int breadth. I am just using b here, and I am implementing the function body, that is return length into breadth. Now I am going to write another function for calculating the area of a square. Here I am writing int area. I am using only one argument here, that is int length. The function's implementation is return L into L. Now I am calling this function. We can see which function is getting executed or how internally compiler is identifying these functions. Then I am writing int main. Assume I have int length which is equal to 10, breadth which is equal to 20. Now I am calling this function. Here I am writing cout. I am just calling area. I am passing length as well as breadth. Length comma breadth. Now function is returning 0. This is my product. Now the question is how the compiler is identifying which function supposed to call without any ambiguities. Now we have another concept here. So we have to discuss about another concept, that is name mangling. The verbal meaning of mangling is changing the shape of something such a way that it is not possible to recognize the original one. In our childhood center, what we used to do, if we are seeing some poster of some superstar and all, we will draw some mustaches and beard and some cooling glasses and all. Then after some time, we are unable to recognize who is that person itself, such a way that we are doing some decoration over the superstar's faces. Do you remember, right? That is we used to do in our younger days. The same way, the compiler also doing some decoration. He is changing the shape or changing the name of a function such a way that user will not understand itself. That process is known as name mangling. But the name mangling is did happen only with help of number of arguments, type of the arguments, and order of the arguments in which we are passing. Third one is order. And fourth one is the scope. Name mangling is nothing but changing the name of the variable or changing the name of the function with help of number of argument, order of argument, type of the argument, scope of the arguments or functions. This is known as name mangling. Now we can see here name mangling is nothing but changing the name. In C++ compiler, except main, compiler will change the name of all the variables as well as all the functions. But in C, there is nothing known as name mangling. But in C++, compiler will change the name of all the functions as well as all the variables. Now, for the user, the name of the function is area. But for the compiler will change the name of this function as the name of this function for the compiler is underscore area. Then compiler will check what is the type of this argument. Type of this argument is integer. Then again compiler is checking the type of this argument. Type of this argument is integer. Now for compiler, the name of this function is underscore area. And next one is compiler will check the type of the argument. Type of the argument is I. Now you can see there is two distinct functions with different name, but for the user there is a single name, but for the compiler the name of the function is entirely different. Here name of the function is underscore area underscore I. Here the name of the function is underscore area underscore I. So there is no confusion at all. Now compiler is renaming the function with help of number of argument, type of the argument, order of the arguments. Now they can see there is a function invocation. Now here compiler have a possibility for invoking two functions. There in this scope there are two functions are available. First function is underscore area underscore I underscore I, and the second function is underscore area underscore I. There are two functions. All these functions are known as candidate functions. There are two candidate functions. From these two candidates, compiler is selecting the viable function with help of checking the argument. Now here you can see there is one argument and there is one more argument. First argument which is of the type integer, and second argument also which is of the type integer. So compiler is identifying this function he is supposed to bind. Now at compilation time, compiler is checking the number of argument, type of the argument, order of the argument, and scope of the function. Compiler is taking a function called resolutions. Function called resolution means which function supposed to call. That process is known as binding. Binding is nothing but at compilation time, compiler is identifying that which function supposed to call depend on number of argument, type of argument, and order of argument. Compiler is making a decision such a way that he is supposed to call this function, and that process is known as binding. Binding is nothing but function called resolution. Since this binding which is happen at compilation time, this is an example for compilation time polymorphism. Compile time polymorphism. And again, this is also known as static binding polymorphism. Again, which is also known as early time polymorphism. Since compilation is the earlier stage of a program execution, this is also known as early time polymorphism. Static binding means this will always bind to this function only. It is not possible to change this binding. That is why this is known as static binding polymorphism. Since this function called resolution or binding which is taking place at compile time, this is known as compile time polymorphism, or this is also known as function overloading. Function overloading. Now we can rewind what we have discussed. It will be like polymorphism means a single function name which is exists as or which have different implementations. Again, here you can see a single function name but implementation something different. Now depend on the time at which compile or this binding which is taking place, this polymorphism is classified into compile time polymorphism as well as runtime polymorphism. Compile time polymorphism means binding which is taking place at compile time. Binding is nothing but function called resolution, that is known as binding. Now how compiler is internally identifying the function is with help of name mangling. Name mangling is nothing but compiler is changing the name of the function with help of number of argument, order of the argument and the type of the argument. Now you can see for the user the function name is area, but for compiler the function name is underscore area underscore I underscore I. Here for the user the function name is area, but for compiler the function name is underscore area underscore I. Now compiler have different choices for invoking the function. All these functions are known as candidate function. There are two candidate functions. Then compiler is selecting a viable functions. From the candidates, compare this is the viable solution or viable function. From a set of candidates, selecting a viable function, that is also known as binding. Or binding is nothing but making a function called resolution. That process is known as binding. Here binding is happening at compilation time. This is known as a function overloading, which is known as compilation time polymorphism. Again, which is known as static binding polymorphism, because which will bind always this function only. Since the compilation time is the earlier process of a program execution, this is also known as early time polymorphism. Hope you understood the concept of function overloading. Function overloading is nothing but a single function name exists as or which have multiple function definition, but the function called resolution which is taking place at compilation time only. That is why which is also known as a compilation time polymorphism. Thank you for watching our channel. If you have any questions or any doubt, you can comment down. I will be explaining your queries. Thank you.